Hey class, so today we're going to be talking about solving equations for a specified variable. Let me just get my pen. Okay. So I should be able to write now. Nope. Okay. Let me try this one more time. Okay. So we're talking about solving equations for a specified variable. Here we have some steps, and these steps are going to look a lot similar to steps you've seen before. So we have step 1, multiply on both sides to clear the equation of fractions if they occur. Step 2, use the distributive property to remove parentheses if they occur. Step 3, simplify each side of the equation by combining like terms. Step 4, get all terms containing the specified variable on one side and all other terms on the other side by using the addition property of equality. And step 5, get the specified variable alone by using the multiplication property of equality. Okay, so if you haven't finished writing all of these steps down, I advise you pause the video and finish writing these steps down before we move on. Excuse me. So here we have our first problem, our first example. So this should say solve, first of all, not sove. And sorry, I thought I had to sneeze. And here it's going to say what we need to solve for. So in this instance, we need to solve for L. So we have our equation V is equal to LWH. And if you haven't already put this to, or if you haven't already seen the connection, we only have to focus on step 5 of our steps because there are no like terms, there are no parentheses. We don't have to use the addition property to move things on one side or the other. We just have some factor multiplying our L. Now, you might notice that in this problem, what's multiplying our L's are variables. But the important thing here is that it's telling us what to solve for in the problem. So really L is going to be our only true variable that we're trying to solve for. This is basically saying that V, L, or sorry, not V, L, V, W, and H have some known value, or we want to plug in values for those and see what our L is. So we're going to treat them just like we treat regular numbers. And in this case, what we're going to do with step 5 is we're going to divide both sides by W times H. And this is just using the multiplication property of equality. And this will give us V over WH is equal to L. And that's all we have to do for this problem. That is how you solve this for H, or L. Alright, so let's scroll down, see what we have. Alright, so here we're going to add another step. In this next problem, we're going to solve y equals mx plus b for x. So I'm just going to rewrite the problem here. Y is equal to mx plus b. Excuse me. And we want to solve for x. So here we do have to use the addition property of equality. You should pause the video now and try to see if you can solve this completely. Okay. So the first step we're going to do is we're going to subtract b on both sides to get rid of that b on the right hand side. And this leaves us with y minus b is equal to m times x. And here we find ourselves in a similar situation as we did in the last example. We just have some variable multiplying our x. So in order to get this x alone, we're going to divide both sides by m. When we do this, the m on the right hand side will cancel out, and we just get y minus b over m. Excuse me again. And that is going to be equal to our x. Okay. So in our next example, I want you to try to solve this for yourself. Okay. Here we have something that's a little tricky. The first step should be fairly easy for you guys. Um, Actually, not necessarily. You might be tempted to distribute this D. However, in this example, we are solving for D. So remember how in the first example I talked about how all these other variables that aren't what we're solving for are kind of like they're not like the one true variable that we're trying to solve for. So we can kind of treat them like numbers. So this n minus 1, even though it has a variable in it, we're going to still just treat this expression as a number. So our first step is not going to be to distribute. It's actually going to be to move our f over to the left-hand side. So now we're left with n minus f is equal to d times n minus 1. And just like when we have a number multiplying our variable, we're going to use a multiplication identity, or multiplication property of equality, and divide by n minus 1. On the right-hand side, these two expressions in the parentheses will cancel out that n minus 1. So we're left with capital N minus f divided by parentheses lowercase n minus 1 is equal to d. So if you ever feel like maybe this is confusing you, I suggest like pausing the video, maybe thinking about it for a second, going through the example on your own, and then maybe looking back at previous examples if after going through it on your own and thinking about it, you still don't quite get it. If after looking at previous examples, please feel free to reach out to me. Okay, so here we have another example. We have f equals 9 over 5c plus 32. So in this approach, I'm going to try something a little bit different to see if this helps you guys understand how to deal with fractions and equations. So I noticed that sometimes my other explanations either weren't clear or were confusing when it came to handling fractions. So in this time, what I'm going to do is suggest trying it this way. So we have a fraction multiplying our variable, 9 over 5. Now, how do we get rid of this fraction? Well, we can look at the reciprocal of this fraction, 9 over 5, or we could look at the reciprocal of simply 1 over 5. Now, why would you want to do this? Well, if we multiply by the reciprocal of 9 over 5, we're going to end up with more fractions to deal with. However, if we just look at the reciprocal of 1 over 5, we won't end up with fractions. The reason for this being, or more fractions I should say, the reason for this is because the reciprocal of 1 over 5 is just 5. And when we multiply a number by 5, we don't get a fraction, we get a whole number, as long as that original number is a whole number. So let's just do it and hopefully that'll make sense. So we're going to multiply both sides by the reciprocal of 1/5. So we'll have 5 times f, and then we'll have 5 times parentheses 9 over 5c plus 32. Okay, so now we're going to have to distribute this 5 to both 9 over 5c and this 32. And this will equal, I'm just distributing this just to kind of clarify this. So I'm distributing this, 5 times 9 over 5 is just going to be 9, see? So let me just write that over here. 9 over 5 times 5, these cancel out. So that's why I can just say this equals 9. Okay. And then you can use your calculator to find 5 times 32. Unless you can do it in your head, that's totally cool if you want to do it in your head too. But either way, you should get 160. as your answer. Okay, so I hope you see now why I talked about the reciprocal of 1 over 5, because when we just do the reciprocal of 1 over 5, now we have all whole numbers here. Okay, so let's see what to do next. Well, we want to solve for c, so we're going to subtract 160 on both sides, which leaves us with 5f minus 160 is equal to 9c. Then we want to get c alone, so we divide both sides by 9. And we get c is equal to, c is equal to 5f minus 160, all divided by 9. So there we have it. That's the answer. Okay, so let's take a moment. Well, let me just scroll down here. Yep, okay, I thought that was it. All right, and that is it for this section. So we talked about this time solving variables, and solving for a variable in an expression, right, for specified variables. And last time we talked about finding or solving for equations in word problems, right, using our equations. And those equations we found up here. If you didn't jot these down, here's the formulas you might run into again. And this is all for chapter 2.6. So I hope you guys understood. And if you have any questions, as always, feel free to reach out. See you next time.